So can you slow it down a little bit when you ask me some questions? Because sometimes I
Okay,
miss
okay,
a
okay.
lot of words. Yeah, thanks.
Okay, okay, okay. No worries, no worries, no problem. Okay.
So it's on live right now?
Yeah, I guess it's live.
Mm.
So hey, welcome to this AMS session. So today we are gonna have a discussion regarding how to build and deploy secure smart contracts on Solana. So would request you to give a quick introduction about yourself, like what you do and all.
Hello, I'm Deok Jang from South Korea. I'm a co-founder of ATIV Studio. We are creating a Web3 music label on Solana network. Like we are building token systems, NFT systems, and utilities behind it, and also like NFT QR drops or gift cards using the Phantom wallets or Solana Pay and stuff. So we are basically a tech company that has power to engage a lot of musicians onto the Web3 spaces. And I'm the one who are in charge of developing Solana contracts. And
Yeah,
that's the reason
okay.
why I'm here right now. Yeah.
That's literally awesome. So let's begin this session regarding how to develop secure smart contracts on Solana. Yeah.
Yeah, so I'll do something quick like just the index. So like I'll explain about what the parallel execution is and the smart contract architecture on Solana and how to create smart contract using the Anchor framework, which are similar to the hard hat in EVM, and how you can deploy and modify smart contract on Solana. What are the attack vectors on Solana contracts? And lastly, the recent exploits like Wormhole Bridge,
Okay.
Cash.io, and Mango Markets and stuff. So parallel execution is not familiar to the EVM Solidity developers because EVM doesn't support the parallel execution of the transactions, right? So staking Ethereum, like you guys will know better than me because you guys are expert in here. So basically, they have EOA and CA. So native Ether amounts and stuff are stored in EOA accounts, and other stuff like states ERC20 or ERC721 and stuff, the balances or many stages on the network will be in CA. So, which means one contract has the logic and the data at the same time. I say data, it means storage. So when you're trying to uh, transfer the same top token, the ERC20 token, but at least send it to the Bob, and at the same time, Deadpool sends it to Spidey. Like both transactions has to change the same contract, and which means they have to be executed step by step. So that is the cause of the bottleneck of transaction execution in EVM networks.
Okay.
On a Solana account, when you look at the data scheme, they have flagged whether they are executable or not. And so which if the account is executable, then data in the account is the data that has only the logic. And if the executable is false and the data in it is the storage. So it enable for like, and you see the Solana transactions, there will be header, the number of signatures and number of accounts and number of instructions, and also account addresses that which account should we refer, and block hash. Like Solana transaction has no nonce. Like they check whether only the block hash. So like the transaction is sent it before 50 blocks away from right now, and also instructions. Which works do you want to do? And also they had the signatures of signers in Solana transactions. So let's say when you're trying to transfer the SPL token, it's like a ERC20 in Ethereum or EVM. They have to append the token program's address and Alice's states of this token and Bob's state of this token in one transaction. And then the validator changed the Alice's states account and Bob's state account at the same time. And this enables massive parallelization because like you don't have to write the same contracts like EVM, like because every balance of token are stored in different accounts. So if you are trying to write the data on different accounts, then you can do it separately. So, and there's a reason why Solana validators hardware spec needs GPU specs because they have to execute the transaction in parallel. So let's say simple, like Solana smart contract concepts, like think of Solana network as an operating system. So cluster, the network created by the validator node is working as a single computer. And above this hardware layer, there is OS called Solana. Each account in Solana can be filed in OS, and some files are executable and others are not. So account address is work like a file name, and name of the file that can be executable will be program. So program name will be the program ID. And the data in file can only be changed by certain programs. Like let's say .doc can be changed by only Microsoft Word, or JPEG, like JPEG, PSD can be changed by Photoshop and stuff. So you cannot change the same file at both because the OS block the referring it at the same time, right? So this is the basic concept of Solana transactions, Solana states, Solana accounts. And let's see through the smart contract architecture. So when you see through the directory of the Solana contract, there are 5 key concepts: entry point, instruction, processor, state, and error. So contract flow will be like some TX called the entry point of the logic, and then the entry point forwards the arguments of TX to the processor. Processor refer the instruction and decode the instruction data that given by the entry point function. Processor decide what function should be called in the full logic. And then lastly, processor may refer the state to encode the data. Like I'll explain it in detail in next slide. So this is the Rust code of the entry point. So you are using the macro because they are giving us the framework for creating a Solana contracts in Rust. As you can see, the entry point macro gets the arguments for process instruction function, and they have 3 arguments: program ID, account, and instruction data. So the validator get the transaction and they separate, they decode the data and then put this 3 arguments in the very first function. And then processor run the function called process that it decode the instruction data and match which instruction should they use to do the logic in transaction they want. So this is the definition of instruction. So like, let's say you want to initialize the mint, which means you want to create a new token. Then initializing a mint, you have 3 arguments, and they have methods for pack and unpack the instruction data. And state are how you're gonna store the data in the account. And also they have a pack and unpack method for the serialized buffer in account. And error is the kind of event emission of Ethereum or logging. So like if something goes bad in the logic and they emit the error and they are declared before, like this format. So Anchor is a framework like Hardhead that enables you to create smart contract more easily. You don't have to know all about this. You don't have to implement every method for pack and unpack those. Like as you can see, you have to know every length of the bytes that you are sending to the contract. Anchor does it for you. So Anchor is a framework for Solana. Solana C-level runtime is the parallel runtime environment for convenient development tools for writing smart contracts. So this is the very simple, like hello world for Anchor. So you just
Yeah.
have to declare the function of what program you have, and then you just have to declare what accounts you are get for the instructions. It's kind of an input and the logic, which in the more simple way. So a construct is like how you're gonna get accounts. Like as you can see in set data is instruction, and to do this instruction, you have to get append the account called my account, which are which store data in state struct in my account like this: pop data u64 and age u8. And you also can create you can also declare errors more easily using the Anchor framework. Deployment on Solana. So like Solana, you can write a smart contract with C, C++, or Rust, because Solana is using some formats called ELF or eBPF.
Mhm.
So everything that use LLVM can use for Solana smart contracts. So when program author try to deploy the contracts, then they Solana transaction has the byte limits. So they scatter it and they send it to the network. And BPF bytecode verifier checks whether this is leased or not. And then they store it on the program account. And when user trying to use the program, they first call the BPF loader and they load the data from the program account, and then they interpret it and then do the logic. So this is the BPF loader program that are deployed on mainnet Solana right now. So every single transaction history in here are deployment on Solana network. And it's quite easy that Solana Labs created a CLI for every steps. So you just have to compile your smart contracts and deploy it. So, and this will be the a very uh, fun parts of this board session, attack vectors. So C-level attacks, like there are a lot of cases for attack vectors like sign authorizations. Like for EVM, you have to check with using the requirement, like the signer is this account or not. You have to do that. And also account data matching, which means like fake account data can be sent it to the network and act like they are original data, and then they can uh, the wormhole, the portal breach was hacked by the account data matching, and also CISPR address checking. These are also how the wormhole breach got hacked. So they didn't check the correct address of the CISPR, so hacker put the wrong address that has similar data to the CISPR original account has, and they get like $300 million, right? And owner's check. So owner in Solana is like I told you that there is a file and there's a program that only can change the data in the file. And in
Yeah.
Solana, they call that program owner. So you have to check owner
Mhm.
whether you have a right to change data or not. Type cosplay,
Okay.
initialization. Initialization is very fun thing. Like in Solana, you have to pay rent for initialized accounts for a certain amount of data length, and you can reinitialize it to reset the data if you don't have a proper checking function inside the smart contract logic. Arbitrarily, CPI is also the bad thing. CPI is the shortened word for cross-program invocation. So you want to invoke like a program A, but hacker puts another address of program B and then invoke it inside the smart contract. So in CPI is the calling smart contract in the smart contract, and you are calling the wrong one if you don't check this number 5 one. Duplicate mutable account. So you can duplicate mutable accounts, means you can dump the data from the network, and then you put it in arbitrary account and then send it, tweak a little and send it to the network, and hackers can get any info that you want. Bumps is canonicalization. So it's about PDA concept in Solana. So PDA is for program drive address. So most accounts are from the curve, right? Their public key and the private key are the pair from the curve, but PDA is quite different. They are hashed from the certain seed. The reason why they're doing this is Solana, you have to put every account in same instruction, right? And which means you have to memorize every arbitrary address to do some stuff.
Yeah.
So yeah, they made something called PDA, so you can control every account by using the seed conventions. PDA sharing. So PDA can be only be signed by program, and PDA sharing, like it's quite, let's see. So when you see this, like you try to withdraw tokens from a PDA, then you are using the similar seed to the former one, but to be secure, you have to check that when you give the instruction, you have to check whether this pool, the PDA, has something called vault in their data and withdrawal destination in data. So they check they are eligible to do something actions. And lastly, closing accounts. So in Solana, accounts are rented. So we have to pay rent to network to using the account. And you can make your account rent exception when you pay a 2 years amount of rent in once. So that means you can close your account if you put rents out from the accounts, and then accounts disappear in not one, like 4 slots or something. So hacker can close your token accounts and get your tokens out of it. Or they can even shut down the whole DeFi system by closing every account in the system if you properly didn't block the enough. So the reason why I explain every vectors is to do the exploits on Solana. So Portal is one of the famous cross-chain bridge in this ecosystem, and yeah, they got hacked. How they got hacked is that in Solana transaction, one transaction can have several instructions, and each instruction can refer other instructions. So originally, Portal has free AA signature, and there are verification and creation of free AA signature in one transaction. Hacker, you see the number 4 account. Hacker changed this Decipher instruction, which are the original instructions that should be in it, to the custom one they created. In that way, they can put a fake signature in it. And then with that fake signature, they are able to mint a Portal ETH on Solana every time they want, because nobody are checking this is from the Ethereum or not. In that way, they created, like, how much was it? Like when you go direct, you can see the number of how much they got hacked. 326 million dollars was hacked by this way, and then hacker moved that Ethereum back to the Ethereum network using the Porter bridge, and then used the Tornado Cash and cashed out. This was the one of the biggest events on Solana, and the other one was the Cash.io. So they they stopped their web page. This is it. So Cash.io is the one that, so there are stable swap in Solana called Saber, and when you deposit your stable coins in Saber, then you can get LP tokens, right? And Cash.io let you collateralize the LP token and print the same amount of stablecoin called cash. But the problem was they didn't check the mint address properly. So which means even though the address of the token was not the actual LP token, the hacker were able to print the money whenever they want. And the sad thing was Saber has the pair of like USDC cash pair or USDT cash pair. So hacker print the money and then swap it on the Saber, and cash price go deeply, and the project got rugged and they stopped making it. The last thing was Mango Market. Mango Market is not about smart contracts. It's more about like in Ethereum, what is it, like flash loan attack. So they exploit the system by the logic, not by smart contract. But I bring it because it's quite new and people gonna love it. So Mango Market exploit is in simple. Mango Market able you to do future and leverage trading, and also they were using the Serum CLOB for their spot market trading. So hacker created two accounts and put massive amounts of long positions and short positions at the same time. So he can have a hedge positions, and then he bought a massive amount of Mango to increase the price in spot market, and that was possible because Mango was not that liquidity on the DAX. And the funny thing about Mango Market is they enables you to land money by the position. So which means your long positions have like 200% of PNL, then you can borrow money in that position at that time. And he drained all lending pool in Mango Market and he cashed out using the governance, because Mango is the governance token. So he passed the governance that they are not gonna sue the hacker. Yeah, this is actually this is all about like 4+ hours sessions, but trying to be quick for the AMA. So yeah, thank you. So this
Yeah.
is my Telegram and Twitter.
Mhm.
Follow me.
Yeah. The session was awesome. Like you literally explained in detail regarding each and every attack occurred regarding the Mango Market ones and the wormhole bridge exploit. An
Mhm.
awesome session. This could be much longer as well, but due to time concern, we have to cut it to only the 40-minute ones. But we'll surely have a long session with you regarding all these things. And yeah, so thanks for this session. Thank you for taking out your time, your precious time, and like educating each and everyone about the Solana smart contract development process and all the hacks. So yeah, thank you for this session. Would you like to say something to the viewers? Anything end note from your side?
If you guys have any questions, no. If there's not, then thank you for listening. Like I was so trying to be quick because not many times for us, but hope you guys enjoyed it.
Yeah, yeah. Thank you. That was it. The end of this session.
Thank you.
Yeah. Okay.